Students, for discussing the properties of rational number, I have made this PDF. This is written PDF by me. So in NCERT book it has been written which is difficult to understand. So I have made it in easy and lucid manner. Okay. So let us start the property. These are the property which we have to study. Closure property, commutativity, associativity, and distribution of multiplication of addition. These four property we have to study, and we have to study these property for rational number. Before studying rational number, we should watch this for other numbers such as natural number, whole number, and integers also. So let us discuss first property, that is closure property. Okay, now first it is closure property. Closure means closed. Closure means closed. In this case, this I have made a box. It means closure means that in this box, you suppose you keep all the numbers. First, if we are discussing of whole number, let us discuss for whole number. Suppose it is a box where all whole numbers are kept. Okay, 1 2 3 0 5 6 and so on, it is kept here. So this says that if, see here, closure property, what it says, states that if suppose a and b are taken from this box which contain whole number, if a is also whole number, b is also a whole number, and we do addition between a and b, we get c. If c also is from this box, that means c is also a whole number, then whole number is said to be closed under addition. Okay, are you getting it? For example, see, I have written example. Let's see this example. 2 plus 3 is equal to 5. Here see, 2 is also whole number, 3 is also whole number. On adding 2 and 3 we get 5. It is also a whole number. Hence this all three comes from the same box, same closed box. Hence we say whole number is closed with respect to addition. This was the case for addition. Now let us move to multiplication. Okay, so this one is multiplication symbol, and if we take a and b from same box, if we are considering for whole number, take whole number. If you are considering for integer, take integer. If you are considering for rational number, take rational number. Okay, if you will take, and you will see that c is also seen from the same box. If you are taking a and b as a whole number, and c is also a whole number, hence we say that a whole number is closed with respect to multiplication. And if suppose we take integer, what is with integer? If we take a as an integer, b as an integer, and we get c also as an integer, then we say that integers are closed under multiplication. Okay, on checking this, we will find out the points that whole number and integers and rational number, all these three are closed under addition and multiplication. They are closed under addition and multiplication, but in subtraction and multiplication the case is different. Okay, the case is different. For whole number there comes a problem. This you can understand this with this example, 2 and 3. If we subtract 2 from and 3, that means if you subtract 2 from from 3, we'll get -1. Is -1 a whole number? No, -1 is not whole number. Hence we will say that whole number is not closed with respect to subtraction, or you can say whole number is not closed under subtraction. Okay, in case of division also the same case arises. 2 and 3, 2 and 3 are whole number, but on dividing 2 and 3, do we get whole number? No, we does not get whole number. Hence it is not closed under division. But if you see for rational number, you will get something interesting. and integers, in integer it is closed. You can watch that -1 is in integer also, hence integers are closed under subtraction, but integers are not closed in case of division, because 2 is also integer, 3 is also integer, but 2 by 3 is not integer. But in case of rational number it can be, but some conditions are also there. 2 is a rational number, 3 is also rational number, 2 by 3 is also rational number. But you think, if we replace 3 by 0, 0 is also rational number, so we can write 2 divided by 0. But this is not definite. So in this case you will say that rational number is closed with respect to addition if we exclude 0 from rational number. Okay, r minus 0. For this set only division is applicable. Okay, this is about the closure property. Are you getting closure property? Closure property means a closed box. If everything comes under the closed box, then it will be said that it is closure. But if some come outside it, then it will say it is not closed. Okay, so it is about the closure property. Next come commutativity. Okay, commutativity what state? It states that if a plus b is equal to b plus a. Okay, if you do operation from either side, the result will be same, then it will be said that this is a commutative. Okay, it satisfies commutativity rule. For any of the number, whole number, natural number, integers and rational number, you will find that addition and multiplication are commutative. Okay, you see the example. And obviously we know that for subtraction and division the answer changes, that is they are not equal, hence we will say that rational number are not commutative under subtraction and division, but they are commutative with addition and multiplication. Now let us watch for associativity. What does associativity say? Associativity say this: a plus b with bracket b plus a plus b when added with c gives again a plus b plus c. You see it? You can watch that for addition and multiplication the things are associative for all whole numbers, integers and rational number. Okay, so rational number satisfy these, but for subtraction and division you won't find it. See, from example you can watch it: 2 minus 3 minus 1 and 2 minus 3 minus 1. Here you can see that here this side comes 0 and this side comes -2, they are not equal, hence we say that subtraction is not means rational number is not associated under subtraction. Okay, so you have learned about these properties. Closure property you have studied, commutativity you have studied, associativity you have studied. Now come distribution of multiplication over addition. This is true for all rational number, and something is true for rational number, then it will be true for whole number. Is it possible? No, it is not possible, but reverse is possible. You have studied earlier. See this figure. Here the circles indicate that whole number contains natural number, integer contains whole number, and rational number contains whole number, natural number and integers, all these three. So if there is some valid property for natural number,